Hi everyone, we are at O2 Surf Tower up in the treetops. I'm going to talk about energy modelling. So with all our high performance healthy homes and passive houses, one of the processes we take the buildings through is energy modelling. Now, energy modelling is not a building code requirement. For us it's essential with a passive house, but even for projects that are not targeting passive house, we are looking to optimise the thermal performance of the building. And so that requires a whole lot of data inputs around the thermal performance of the wall assembly, the thermal performance of the chosen windows. So in this case we've got the Stark Ambience UPV suite with double glazing, the insulation in the roof and the floor, whether it's a timber floor or whether it's a slab, and also the airtightness target of the building. Again, not a code requirement, but a tangible, measurable data point on the efficiency of your building. What we can also do with energy modelling is understand shading and understand overheating. So on a house like this, we will understand the impact of the big trees and the shading that they provide, and that does two things. Around in the summer, does that help us with overheating, or in the winter, does that hinder us getting some beneficial heating from the sun? So we input all those, we model the trees, believe it or not, in 3D. With this house in particular, at the moment they're not on there, but you can just see the scaffolding there. But when this is finished, instead of scaffolding, we'll have some over window shades, call them eyebrows, some slats, and the idea with them is to block out the high summer sun, and with that reduce the amount of solar rays on the surface of the window, therefore penetrating into the house and heating it up. In the winter, the low angle sun gets up and we get that beneficial heating. From the energy modelling from the 3D and then into the software, we can then pull the different levers. What if we give it more insulation? What if we use a better window? What if we make that window shade deeper, shallower, take it away? And then we can get the optimum balance for the performance of the building that we're targeting, and as such work out what the energy demand for the building is. And so we can just work out how to get the best value, and sometimes it's a cost calculation. How much is it going to cost up front to achieve these results, and if we do it this way, that way. And then others might be just chasing a really high performance target, so therefore just looking where do we need to do that. So if you're interested in getting the most out of your building, energy modelling is where it's at.